Hi, welcome to this course on XML languages. Today we will talk about general XML extended markup languages, that is XML itself, then XHTML, which is a rewrite of HTML in XML, and extended style sheets, XSLT, which is a version of cascading style sheets for XML documents. Moving on. First I should say that although XML languages it's very important for the World Wide Web space, because together with HTML and HTTP, although a little bit less important than HTML and HTTP, but together with them it forms one of the building blocks. It is one of the building blocks of the World Wide Web space. XML, the XML language is a meta language, which means that it is used in order to define some other languages. Examples are XHTML, XSLT, RDF for semantic web, resource description format, Smile, which is not used that much anymore for specifying audio-video presentations on the web. Then MathML for writing mathematical equations using XML, also on the web, and several others. The popular XML is also used usually for configuration files for various servers, web servers, IDs, databases, and it had, well, it is still popular, but recently, in recent years, its popularity decreased as new textual representation formats appeared on the web, namely JSON, the JavaScript object notation, and we will talk about the JavaScript object notation next course when we talk about JavaScript and server-side programming. So, although its popularity decreased in recent years, XML still remains highly used on the World Wide Web space and outside the World Wide Web space. And in this view, this course is important, but everything that I'm talking right now, it's important only for the final exam, where I may ask something from this course, but otherwise I've removed, starting with the previous year, I've removed the XML lab that you need to the XML lab that's on the Impulse platform, so you don't actually have an XML related lab task. Although this course is important for the final exam, which I don't know when will happen, or the form in which it will happen. Normally it should be a practical exam, but we'll see. Okay, so moving on, we start first with XHTML, which is just an application of XML. It is just a specification of a more stricter specification of the HTML language, and the name XHTML comes from Extensible Hypertext Markup Language. It's just the HTML language defined with a stricter syntax. So it's HTML defined as an XML application. It is stricter and cleaner HTML. It's compatible to HTML 4.01 and supported by all browsers, and is a W3C recommendation. Okay, why do we need XHTML? Well, as you already know by now, as you already know by now, HTML has some rules, meaning the document should have an hierarchical structure. Everything should be enclosed in the HTML tag. that you see here. Then the HTML tag should have two children. One is the head, the other one is the body. The head should contain metadata about the current document, so not actual data. And the body should contain all the rest, or the actual data of the document structured into sections, articles, and the like. But as you've already seen, the browser is quite friendly, and even if the HTML document is not specified correctly, the browser tries its best to interpret what the writer of the document intended and display something in the browser screen. For example, this bad document will work fine in most browsers, even if it doesn't follow strict HTML rules, meaning that so for example here I have the head tag, which is not closed, then I have the body tag, which is also not closed, this paragraph is not closed here, the anchor doesn't end here, and so on. But so most browsers will display this document fine. But some devices which don't have so much which don't have much computing power, they can have troubles interpreting this bad HTML document. The HTML language is designed to structure and display data, but XML is designed to describe and structure data. Okay, so it's more powerful than so XML is more powerful than HTML because besides structuring the data, it is able to also describe the data. An observation here is that the display functionality of the HTML language was initially included in the language, but later on, starting with HTML4 and then 5, this functionality moved to a different language, which is, as you already know, cascading style sheet. So not that much displayed, but the structure functionality belongs to the HTML language. So XHTML specifies that everything should be marked up correctly. In the next slides, you will see the rules that XHTML brings to HTML, which all the rules are written with this philosophy in mind that everything should be more strict. So, for example, if you start a tag like this P, you should also close it somewhere. And we will see these rules in the next following slides. There are not that many. So these base syntactic rules are XHTML elements should be properly nested. You see here an example written with red text, red color. So this one is not good because this italic starts here and ends here after the bold tag. So the properly nested version of this would be this one. So the inner tag is I and the inner closing tag is also I here. Okay, and the B tag should be on the outer edge. Then XHTML elements must always be closed, so this is not okay. Starting a paragraph here and never ending it. Also break here, and also this image is started here and it doesn't end. So the proper way of writing this is this one. So you start this paragraph here and you end it here. And then there's also a shorthand notation for tags that don't actually contain any inner text, like this one, and also this one. So if you don't want to write the closing img tag, you can still close the tag using the slash inside the starting tag, the img, like this. Okay, XHTML elements should be in lowercase. XHTML elements should have only one HTML root element, which contains a head and a body. As you already know, like in HTML, I can add two HTML tags or several head tags or several body tags, and it will work mostly fine on any browser. Okay, in XHTML, this is not allowed. Some other rules. as the tag names are written in lowercase, also the attribute names should be in lowercase. The attribute values should be quoted, so not like not like this. If I can underline this. So not like this, but instead it should be written like this, using quotes, using the double quotes. Okay, this one. The ID attribute replaces the name attribute. Then there is a document type definition, which is another document that defines the mandatory elements. We will talk more about DTDs and XML schemas later on today, but basically what this do, so an XHTML DTD is just a document that defines the order and the number of the tags in any XHTML document. It also defines the children of a specific tag. So for example, in the head tag of an XHTML document, there can be no body or HTML tag included as children of a head tag. Okay, attribute minimization is forbidden, so you can no longer write something like this, but instead of this you should write something like this. So input checked and input disabled. Okay, the general format of an XHTML document is this one. So the familiar structure is the HTML tag, which is the root of the document. It has two children, the head and the body, and the usual rules in the head. There are those metadata tags like meta, title, style, script, and so on. And in the body tag, one can include the usual structuring tags like section, article, header, footer, nav, so on. And before the HTML tag, which is the root of the document, we should specify the type of the document, which is written in this doc type specification, which just specifies that this is an HTML document, and the DTD, so the document type definition of this document would be this one. So this one written at this URL. So this DTD document just defines the actual tags that can appear in an XHTML document, the order of the tags, the exact children of each tag, the exact content of each tag, and so on. All these tags, doc type, HTML, head, title, and body are mandatory. Moving on, a document type definition is, as I've already specified, is a document that defines the syntax of a document written in an SGML language. An SGML language is just like an ancestor or an umbrella language. It comes from standard generalized markup language, and it is a meta language that includes XHTML, HTML, and XML. And a DTD specifies, as I said, the hierarchical structure of a document, the element names and types, meaning the tag names and types, the tag names, the tag content, any attributes the tag may have, the attribute names and the attribute values. And this DTD specifies all this information for the document which complies to this DTD. For example, in the previous example, so this DTD, this one, describes all these elements for this specific document that specifies the DTD to which it complies. So this document complies to this DTD specification. Okay, you'll see why this DTD matters later on when I'll also give later on today when I'll also give you an example of a DTD and also an example of XML schema, which is let's see the newest version of DTDs. DTDs are not that used anymore. They were obsoleted by XML schema. And XML 1.0 has 3D. I think this is a mistake. So yeah, this is a mistake. XHTML 1.0 has 3 DTDs: strict, transitional, and frame set. For example, in the previous example, this is the XHTML 1.0 transitional DTD. Okay. There's also there's an example here. This one defines DTD for an XHTML file. This one defines that the doc type of the document which complies to this DTD is course, and the document should contain a course tag, which is this one, which is the root of the document, just like HTML. Just like the HTML tag for HTML documents, and this root tag should contain several lecture tags as children. Each lecture tag is an element which contains the following type of children: title, bibliography, notes, and examples. The title tag defined here should contain parsable character data, that is text data. So it shouldn't contain any other tag inside it, but just text data. The bibliography tag, the bibliography child, should also contain parsable character data. The notes tag should also contain parsable character data, and also the examples tag. And here I have a list of attributes. So it is specified here that the course tag should have a professor attribute, which is required, and the value of professor is character data. The course should also have a title attribute, a year of study a year of study attribute, and the date attribute. This one has a default value. They are all character data, and they are all attributes of a course stack. Okay. So this is a DTD example for an XHTML document. Okay, XHTML validation. So a valid XHTML document, it's an XHTML document that complies to the rules of the DTD specification. The DTD file specified in the doc type tag in this document. There is this official W3C XHTML validator, which checks whether the current document is valid, meaning it complies to the DTD specification. And the XHTML DTD is split in 28 modules. Now moving on to a more general language, that is XML, Extensible Markup Language. Extensible markup language, it's an umbrella language. It is a markup meta language. It is a markup language used to define some other languages like XHTML, like I said, RDF, Smile, MathML, and so on. It is a markup language designed for storage and transport of the data. In relation to HTML and XHTML, the XML language is a language for structuring data, which is the same functionality for HTML and XHTML, but it also has the functionality of self-describing data. So not formatting the data, but self-describing data, which makes it very useful for parsing it by programs, by machines, by programs. as I said, it's a meta language used to define some other languages like this ones. It does not have a predefined. It does not have predefined tags. All tags are defined by the document writer. So these are defined by the users. It is easy readable by both humans and machines. Because it is self-described data, normally a user should understand what this document is about by just looking at the document, by just looking at the tags of the document, and also a machine, that is a program, can parse it, can parse the XML document more easily than some other document like HTML. It is plain text in order to be platform independent and compatible between different platforms. It is software and hardware independent, and it is a W3C recommendation. Because sorry, let me go. Okay, I'll show you an example here. This is an example. This one specifies that this one is an XML document version 1.0. This you see the fact that XML is self-describing. By just looking at this document, you immediately understand, you humans immediately understand that this document is about a collection of books, and each book has a title, author, and so on. It has a category here, okay, a title, an author, ISBN, and so on. So you immediately understand that this document is about books, and it describes books. This is what it means, self-describing data. Okay, XML usage. I've already told you in the beginning of this course that XML was very popular on the World Wide Web space and also outside it. It's not that popular anymore, although it is still used a lot, mostly for configuring, for various configurations of servers, of containers, of IDEs, and so on. It is also used for storing data. It is a competitor of relational databases. For storing data on the web. These are also called, XML databases are also called semi-structured databases, meaning because they are more structured than plain text but less structured than relational databases. As I said, it is a language used for storing and interchanging data. Its popularity, although it is still high, it decreased in recent years for storing and transmitting data in the World Wide Web space due to the introduction of JSON, the JavaScript object notation, which has increased popularity due to the fact that it's very easy to map JSON text to JavaScript objects and the reverse. But it is still quite popular these days on the World Wide Web space and also outside it. So because it is self-describing, it is more easily understood by different incompatible systems which interchange data, and also reduce the complexity of parsing the data. And because it is plain text, it is platform independent. Okay, so this is XML. By default, an XML document loaded in a browser is just its hierarchical structure. So you see, this is an example. This is how this XML document example looks like in a browser. It looks like this, so you just see the hierarchical structure. You have the collection root tag, which contains books, and each book has an attribute category, then a title, author, ISBN, and so on. We have 3 books here. This is the default way of displaying an XML document in a browser. The syntactic rules of XML. All XML elements must have a closing tag. XML elements are case sensitive. They are very similar to XHTML syntactic rules, because XHTML is just an application of XML. XML elements should be properly nested, should not overlap. As you've seen the example in the XHTML case, XML documents should have only one root element, which is the parent of all elements, and the XML metadata tag, this one, is not part of the document itself, just like the doc type is not part of the document itself for XHTML and HTML documents. Values of XML attributes should be quoted. Then the characters, just like in HTML, these characters, smaller, ampersand, and also greater, this one, are illegal. In XML. You should use predefined entities, this little instead of this one, this greater instead of this one, this ampersand instead of this one, this apostrophe, HTML, this apostrophe entity instead of this one, and this quotation instead of this quote. Okay, comments in XML are done the same as in HTML using this symbols. Unlike HTML, whitespace is preserved in XML. Remember that in an HTML document, whitespace, space tab, are not well, they are preserved only in pre-tags, but otherwise they are not preserved. But in XML they are preserved, and XML stores new line as the line feed character, which is the character with the ASCII code 10. XML elements. So XML does not have predefined tags. By the way, so it does not have predefined tags, as you've seen in the previous example. I have this example, which contains collection book. These are not predefined. Since we are here, also know that the HTML language version 5 does have predefined tags, but it also allows you to use user-defined tags. I think I have an example somewhere. Okay, yeah, I have this example which has these tags, so they are not standardized tags, ala bala portocal. Okay, if we load this, sorry, let me open a new tab. If we load this is here, and so there is no error. The document was loaded, and since it doesn't have a cascading style sheet associated to it, it just displays the text of this element, but they are visible here. Okay, so in HTML5 we have predefined tags, but we can also add our own tags. Okay, in XML we don't have any predefined tags, we just add the tags ourselves. Okay, let me go back to the course. Okay, so XML does not have predefined tags. The tags are defined by the user, but the tag name should comply some rules, which are the following. The tag name can contain letters, numbers, and other characters, but it cannot start with a number or a punctuation character. You cannot start with the letters XML, lowercase XML, or uppercase XML, or a combination of lowercase and uppercase letters that form XML. It can also not contain spaces. So you can define whatever tag you want, but it should comply to these rules. An XML tag can contain text and other nested tags, and an XML tag can also have attributes. We can have there are two possible properties of an XML document. One is the well-formedness, So we talk about a well-formed XML document. That is an XML document compliant to the XML syntactic rules. These rules, this one and this one. So this is XML well-formedness and XML valid XML document refers to a document that is compliant to a DTD or an XML schema specification. You don't know what an XML schema is, but it's like it's an alternative to DTD, a newer alternative to DTD, so like the successor of DTD, and it specifies, as you've seen in the DTD example, it just specifies the exact tags that should appear in an XML document and their specific order. A DTD and a schema can be specified inside the XML document after the XML tag, or it can be specified in a separate file and referenced in an XML file like this. You've already seen this. You've already seen an example of how we specify a DTD file in the current HTML document when I was talking about the XHTML language. And the way we can specify a schema for the current document is like this. So it's a newer alternative to DTD, XML schema, and it can be referenced like this. So like this. So using attributes of the root tag of the current XML document. So we just specify this is a default namespace here. And this is the namespace for all the tags that have this XSI prefix, and this is the schema defined for the current document. This one. Sorry. This one. Yeah, like this. Okay. So we have well-formed XML documents that are XML documents compliant to XML general syntactic rules, and we have valid XML documents, which are XML documents compliant to a DTD or an XML schema. The purpose of this is the fact that a non-valid XML document is not loaded by the browser, meaning that if you have an XML document that specifies a DTD or an XML schema and the actual content of the XML document does not follow this or breaks from the rules of this DTD or XML schema, then that document is not loaded, that XML document is not loaded by the browser. Which is very different than HTML, because as I've told you, an HTML document, and as you've already seen, an HTML document is loaded by the browser. Even if you break the rules, you don't close tags, you don't properly nest tags, and so on. But this is not true for XML documents, because XML documents or the XML language and XML documents were created with the idea that they are parsed not only by humans but also by machines, by programs. And if there is an error in parsing these documents, then the program should stop the parsing. Okay, moving on. This is a DTD example for a collection XML document. This is very similar to the DTD example you've seen previously. When we talked about XHTML, you've seen a DTD example about courses. This one is about books. So the root element of an XML document compliant to this DTD is the collection tag. The collection tag can have one or more book tags, as is children, at least one of them. This is what this plus means. At least one of the book should be a child of collection. And then each book has title, author, one or more authors, ISBN and editor tags. Each of these tags, title, author, ISBN and editor, contains parsable character data. And there's also an attribute for book, which is category, which is required, and it contains character data. Okay, this was an example of a DTD document for the collection XML uh, X document, and this is the XML schema variant of the same XML document, this collection XML that you've already you've seen it. It's also here. Let me just show it to you. So we can find here XML examples. I seem to have a problem with the internet. Okay. And the book XML is this one. It is displayed like this because it has a CSS, but we can look at it like this. So it's a collection with books, and each book has a title, author, ISBN. So this schema is for this XML document. Okay, it also defines the here it defines the it references the DTD document, not the schema. Okay, but instead of this, we could have written a reference to the schema document, which is yeah, which I don't have it here. Okay, so let me go here again. Okay, and this schema is quite straightforward now. So this XML schema is also an XML document because of this, because of the first line. Yeah. This one defines the default namespace of the schema. I'll tell you in a minute about namespaces. This one defines an element with the name collection, and this collection is a complex type. It contains a sequence of children, and each child is an element of type book. Okay, which is also a complex type, which has an attribute category of type string. This one. And then it contains as children a sequence of elements, title, author, ISBN, then editor. They are all string. The type of all the elements is string. And for this author, we also have here that some attributes, meaning that there should be at least one author and maximum 10 authors. And then this complex type is closed here, and this element is closed here, and the sequence is closed here. Sorry. Okay, and then the complex type and XML, element and schema. You see that they all have, so all these elements have the XS namespace, which is defined here. But I'll tell you more about this in a couple of slides. So we'll talk about XML namespaces in a couple of slides. So this is an example of XML schema for our collection XML document. An XML schema definition, it's an XSD file, is the successor of DTD, and it's more popular than DTDs because an XSD file is also written in XML. So XSD is just an XML language. Like a DTD, an XSD defines the elements which appear in the XML document and their attributes. It defines the hierarchical order, the hierarchical structure of these elements, the number of child elements of a specific type, whether the element is empty or it has content, default and fixed values for elements and attributes. So it defines all the rules, all the syntactic rules, not exactly syntactic, but it defines the order and the presence of the tags in an XML document. In addition to DTDs, XSD also support basic data types, numerical, date, string. You've seen here this. Here we specify the type of each tag, so the type of the content of each tag. So this one specifies that the value of the category attribute is a string. This one specifies that inside the title tag we have string data. So the actual content of the title tag is string content. It also supports namespaces for solving collisions. I'll talk about namespaces in the next slide, I think. And it uses XML syntax as opposed to DTD, which doesn't use XML syntax. So XSD is another XML-based language. Namespaces, yeah. The purpose of XML namespaces is very similar to namespaces in programming languages, meaning that you have two independent parts, independent texts. Like in programming language, you have two independent classes, and they define the same object. And if you mix them together, you need to be able to say which symbol or which expression refers to which object, the object from the first module or the object from the second module. I think you'll understand better if I'm just doing this example. But XML namespaces, like programming language namespaces, is a tool used to resolve name clashes. So for example, I have here two documents, one containing studies. Yeah, so I have here two documents, or one document with two parts. One containing studies, which defines the year of study, the first year, then group. So the first year of study has several groups, 211, 212, and so on. Second year of study has some other groups, and so on. And then we have courses, which are also grouped into groups. So we have here a group called databases, and we have these courses from this group, and then we have this group operating system, and we have these other courses in this group. And we see here that this group tag means a totally different thing in the courses part, in the courses section, than this group tag which appears in the study section. So this group tag here in the study section refers to a group of people, and here the group refers to a group of objects, a group of virtual objects, a group of courses. Okay. The way we solve this is to define a namespace for this studies part and another namespace for this courses part, and we do this in the next slide here. So we have the same document, but we just define for the studies, for the studies tag, we define the namespace, this namespace, for all the tags that have this st prefix. St comes from studies, but we can use some other prefix if we want to. So all the tags that have the st prefix, like this one. So all the tags from this tag, all the tags from this studies tag, all the tags from this studies tag that have the st prefix are in this namespace. The namespace is defined by this URL. This URL does not need to actually physically exist. It just needs to be unique as a string. And so the year of study here, because it has the st prefix, belongs to this namespace. This group, because it has the st prefix, belongs to this namespace, and so on. But this other group here, because it has a different prefix, co, belongs to this namespace defined here, XML namespace. Okay, and this URL is different than this one. Again, this URL does not necessarily need to actually exist, but it should be unique. This one is different than this one. Okay, and then if I have in a document several group tags, but if they have different prefixes, they belong to different namespace. so that this group, so that a program that parses this document knows that this group, because it has a different prefix which belongs to a different namespace, is very different than this group. Okay. So this is what namespaces are. The namespace, I've already told you this information, that the information that is present on this slide, but let's quickly review it. So the namespace for a prefix must be defined using the XML NS attribute. XML NS attribute can be placed in any tag, in which case it will be valid for the children of this tag, the successors of this tag, so the children and its children. Or it can be placed in the root tag like this. So we have the XML NS attribute, which defines the namespace for this prefix. So the namespace is this one for the prefix st, and the namespace for the prefix co is this one. Okay. Each namespace URI is a uniform resource identifier, which is a superset of URLs, uniform resource locators. Each namespace URI should be unique and should not necessarily point to a physical page containing namespace information. The default namespace for the document can be written like this in the document. In the document tag, we can write XML namespace like this. This is the default namespace for all the tags that don't have a specific namespace in the current document. Okay. I've already told you that loading an XML document in a browser just shows the hierarchical structure of the XML document. If it doesn't have errors, either well-formedness errors, meaning it complies to the syntactic rules of XML, and also if it has a DTD or an XML schema specification, it shouldn't have errors related to the validation. Meaning it should comply to this DTD or XML schema specified. Okay, and if it has error, it is not displayed in the browser. Okay, meaning the XML parser will stop when an error is found. The default, I've told you, the default display of an XML document is just to see the hierarchical structure of the XML document. But an XML document can be displayed differently using CSS rules. The regular cascading style sheets as used for HTML document, or we have a more powerful version of cascading style sheets for XML documents, and these are XSLT, extended style sheet transformation. Okay. We can format an XML document using CSS like this. So the CSS file is referenced in the XML file using this XML style sheet type text CSS text book CSS, and we specify the CSS rules like this. So now we have the book. We have this. I've tried to place all this. I've tried to place the contents of this CSS file into this code block, but I couldn't place it all on only one column without reducing the font too much. So this one, the syntax, so this rules book, this one, sorry, this rule display block and border bottom and width and margin left, margin right specify the style for all the book tags. So all the book tags should be displayed with the type block, meaning a book should be displayed on one single line. It should have a border bottom. It should have a width of 80% of its parent. It should be horizontally centered. The author should be displayed as an inline block with the width 15%. Also, it has a left border, some padding. Also, the editor has some rules here. The title has some rules here. And the ISBN has some rules here. Okay. I think we can look at the example. Okay. So I think I have the examples here. Let me go to. So these examples are the same examples as the ones that are present on the course's website. Let me open this book XML. Okay, this one. Let me open it with Sublime. Okay. Well, we can specify this. Doesn't matter. Let us specify the CSS for this, and we need to comment this one. So the style for this XML document should be either specified using CSS or using an XSL document. So let me comment this one. Let me open also the CSS file, which is this one. So this file is just the one that's present on my slides. This one, okay. So it specifies the style for book, for title, for author, for ISBN, and for editor. Let me save this and load it again in the browser. Now I should go to example, this one, and book XML. Okay, and you see the books displayed in a table. This is the title of the book. It has a background color as specified. The title has a background color as specified here. Okay, some padding, some border left. They all have border left. That's the reason we have these lines. Okay, because we don't actually have a table tag. We don't actually have a table tag in the XML document, but instead we create this table look by using the border left. Using border left for author, for ISBN, for editor also. Okay. So this is how we can display XML documents using CSS. So the regular way is used for HTML. Only that here we have different selectors, different tag names, but meaning different tag names, but the selectors are the same as for the selector types are the same as for HTML documents. Okay, let's move on. So we can display an XML document using CSS, regular CSS, but we can also do it using extensible style sheet language transformations. This is just a quick slide about Xpointer and Xlinks. So there are several XML languages defined for the style of an XML document. One is Xpointer and the other one is Xlink. Xpointer defines a standard way of referencing various objects inside an XML document like this. So this one is a link to a tag with the ID with the ID equal to rock from this document, this XML document, so this link, this pointer refers to the fifth child of type item of a tag with the ID rock from this XML document. Okay. So X pointers are sort of, or they play the purpose of CSS selectors in HTML. Something like this. And Xlink defines a standard way of creating hyperlinks in XML documents. So this one creates a link from the current document to this w3schools.com. Okay. Let's move on to XSLT, and this is the last part of today's course. So XSLT contains several parts. It's extensible style sheet language transformations. It contains this part, XSLT, a language for transforming XML documents, XPath, a language for navigating inside XML documents, and XSLFO, a language for formatting XML documents. We will only briefly touch XSLT in this course. Okay. Extensible style sheet language was developed by the W3C because there was a need of having an XML based style sheet for XML documents. In HTML, we have the predefined tags, although you have seen that we can also have user-defined tags. But for the predefined tags in HTML, we have predefined styles. The style is predefined by the browser. But in XML, since we don't have any predefined tags, all the style information should be displayed by the developers, the users. XSLT or extensible style sheet language is more powerful than CSS. As for CSS, we can only change the looks of an element. We can also let's say we can virtually change the structure of an HTML document using CSS, because we can hide things or show things when the mouse is over something, or when it's outside focus we can hide and show things, but actually the actual tag does not disappear, although visually it disappears, but it doesn't disappear from the document. With XSL, XSL has more powerful features that are closer to the JavaScript language, meaning that we can actually remove a tag and move a tag around in the hierarchical structure of an XML document. So we can actually remove a tag. So we can change the structure of a document using an XML document using XSLT. Let's see how. XSLT is used for transforming an XML document into another XML document. We'll see an example where we take an XML document, like actually exactly the one with books, and we transform it into an HTML document using XSLT. XSLT is the most important part of XSL. Using XSLT, we can add or remove elements and attributes in the XML documents dynamically, just like you would do with JavaScript for HTML documents. We can rearrange and sort the tags. We can hide or display elements. And XSLT uses XPath for parsing the XML document, for locating various tags or various attributes in the XML document. It's not that hard, it's quite easy and straightforward to understand, this XPath. Okay, let's give an example. This is an example. Here it's an example of XSLT. It is just a file that is referenced. It's an XSL file that is referenced in the XML document like this, using XML style sheet type text XSL and the actual name of the file. And in this case, the current XML document in which this XSL document is referenced is transformed by this XSL specification. And what this XSL specification does is actually let me first go through the elements of XSLT, and then we'll come back to this example and explain it. Okay, so let's go through the elements of XSLT. So first we have XSL template. It's a template element from the XSL namespace. Its equivalence in programming languages is the concept of a function. So it's just like a function in programming languages. It matches a specific XPath expression, and it is applied. So this let's call it function. This function is applied to this to the tags that match this XPath expression, and the body of the the template or the function is this one. Okay. So it builds a template and associates this template to an XML element or tag, or to a set of elements and tags as specified by this XPath expression. And a form like this, XSL template match / matches the root element of the XML document. There's no example here, but we can see it here. So this one, actually, let me move to the full screen and then we'll come back to this. So I'll first discuss the most important elements of XSLT and then come to the example. Okay, XSL value of just selects the text value of one or more tags specified by this XPath expression. This is an example which selects the tag with the tag title, which has a parent of type book, which has a parent collection, and it selects the inner content of this title element. Okay. Then XSL for each. This is if the previous XSL selected the inner textual value of one tag. This one, XSL for each, parses the children of one specific tag, and it does something for each children. Okay, the syntax is this one. We have XSL for each. This is the XPath expression which selects the tag to which this for each applies. So this for each applies to the children of this tag selected here. An example is here. So we just select all the books from a collection, and then we select the value of the title tag from this current book, the author tag from this current book. Okay, and we print them on the browser window. Here it's a more sophisticated selection, a more sophisticated XPath expression, where we select all the books from the collection, and those books should have the title child equal to operating system. Okay, so it's a filter on all the books from the collection. It selects only the books that have a title equal to operating system. Okay, XSL sort. This is useful for sorting several tags that are selected using this XPath expression. So it sorts all the previously selected tags based on this title. You'll see an example in a couple of minutes. Then we have an if. Okay. Which selects a tag if this expression is evaluated to true, and outputs this in case this expression is evaluated to true. We can use several operators, relational operators here, like equal, different, smaller, greater. This is an example. It tests whether the title child of the current selected tag is equal to operating system, and if it is equal to operating system, then it performs it outputs this what's written here. You'll see an example of this one in actually after this slide. This is the last slide. This is XSL choose, which is a generalized if. When this condition is evaluated to true, then this would be outputted. When this condition is evaluated to false, this would be outputted. Okay, this is generalized if, just like a switch, a statement in a general programming language. Okay, that's it. Let us see the examples. Okay, maybe we'll leave it with that. Yeah. Let's see the example. So this one is the view of book XML using the CSS file. Okay, let's try to use an XSL file. I have it here. So let's comment this out. Yeah, and let's uncomment this XSL. Save it and see how it. So now the style is specified by this book XSL file. We will load it here. This is the actual book XSL. This is the actual example from, okay, this is the actual example from this slide. From this is the example. Okay, this example is the one that I'm using. Let me save this and then load it into the browser here. Seems I have a mistake. Let me check it out. Yes, this is what happens in, this is what happens in Chromium. If I'm using an XSL style sheet and I load this file from a local source, not from an HTTP server, then I have this warning, this error, and the file is not loaded. But I can load it from here. So I can load it from this server, from the faculty server. So if you want to do this locally on your computer, you need to have an HTTP server locally, or just place the XML and XSLT files on the scs ubbcluj.ro web server, or you can wait until we do the PHP course and I'll show you how to install XAMPP or WAMP. Which it's a bundle containing the Apache web server, MySQL web server, and some other tools. A MySQL database server and some other tools. Okay, let me load it from here. Let me see whether. So yeah, so this one has the style sheet book XSL. Okay, and you see what happens. You see that everything is loaded in a table, and let's see how this is done. We can look at the source here because it's the same. So what this is the XSL file that's referenced in the book XML. So it specifies that this document is also an XML document here. It specifies the default namespace for all the tags that have this XSL prefix here. Okay, so you see that here we have some tags that have XSL prefix and some other that don't. All the tags that don't have the XSL prefix, they do not belong to extended style sheet language, and they are displayed the way they are. So this HTML body, H2 table, they are displayed, they are outputted the way they are. So here we have, this is the root XSL style sheet, the root of this document. It goes up to here. And in this document, we only have one XSL template, which is like a function I've told you, which is applied on the root of the document in which this style sheet is included. The document in which this style sheet is included or referenced is this one, book XML. It is the XSL file is referenced here. Okay, so this template, this function, will be applied to the root of this document, which is the collection. Okay, will be applied to this. Let's see now what the XML, what the XSL template does. So the XSL template just prints some tags, this one and this one, because they don't have the XSL prefix. They are displayed at the output, so they are displayed in the browser window the way they appear. And then here we have an XSL for each, which selects all the book children of the collection, which are these ones, all the books from the collection. Selects this, and then it draws a table row for each book. So this is what happens for one iteration of this XSL for each. So it displays a table row for each book selected. Let me just quickly edit this. And it has 4 table data, table cells here. So it selects the value of the title, it displays it in a table data, the title child of the current selected book. Then it selects the value of the author, ISBN, and editor, and it displays them here. Okay? So that's why we see in the browser, we see for each book a table row. Okay, here. I think we can even inspect this, see if it works. Yeah, So you actually see a table. Okay, you see the head, the body, and you see a table with one book, one table row for each book, which contains the title, the author, the ISBN, and the editor. Okay, so this XSL document took this XML document and transformed it into an HTML document. The HTML you can see the HTML document here. Now it's HTML. No? HTML, body, table, and so on. Okay? So that's a simple example of what we can do in XSL. Okay, let me quickly show you some other examples and then we are done. I don't have that many examples. I have another one here, which is it's XSLT. It's quite powerful. We can actually compute factorial, and you see it here. So factorial of 1 is 1. You can actually program in it in XSLT. Factorial of 2 is 2, of 3 is 6, and factorial of 4 is so it's 4 times 3 times 2 times 1, which is 24. Yeah, and so on. Let's see how this is done. The source of this is just this one. So it's just an array with the parameter. It's just an array with the parameters of the factorial template. So we compute factorial 1 factorial, 2 factorial, 3, 4, 5, 6 factorial, and the computation is done in this XSL file, which is here. We can look at it here, but we will see. Yeah, it's downloaded. Let's look at it here. Now, let me open it here. Okay, let's go to the example. Factorial, yeah. So it's a bit longer, this one. So we have here two templates. So we have here this XSL stash, this is the root XSL. So this is the root of the document. This is an XML document. We have two templates. One is the factorial, which is just a function. We'll come back to this later on. And we have this root function, which is applied to the root of the document, which is this one. The root is this array. The root of the XML document is array containing numbers, and numbers are the actual parameters of the factorial function. So it applies this to the root of the XML document, to the array. It outputs HTML and body, and it selects each number from the array. So each of these numbers, number 1, 2, 3 from the array. Okay, and for each number, it displays in a paragraph the value of the current selected tag, the value of the number. This dot means the current value of the number. And then it calls this template, this function called factorial, with the argument, with the parameter n. The parameter name is n, and the parameter value is the current value of the number. That is this number, actually this one, sorry, 1, 2, 3, and 4. These are then 5 and 6. These are the arguments of the factorial template. Okay, so it calls this factorial with the parameter with the value n, and with the name n, and the actual value, the value of the current selected number. And then this one is closed here. Then we close the paragraph, and then we close the for each, and then we close the body and HTML, and that's it. So every computation is done in the factorial, and actually is done recursively. So this template factorial, which is called here, it doesn't have any match argument because it is called here explicitly. Has a parameter with the name n. It defines a variable with the name sum, which is equal to 1. If the parameter n is equal to 1, then the value of sum is 1. Otherwise, if the value of n is different than 1, we call the factorial template again recursively with the parameter n and the actual value n minus 1. Okay? And then we compute the actual value of the factorial template to be the value of the sum multiplied with the value of the parameter n. So what we actually do here is, in order to obtain factorial of n, we just compute the product of n times factorial of n minus 1, which is computed recursively using the factorial. Okay? So hopefully you've understood this. As you see, XSL is quite powerful, and we can almost program in XSL. So this is XML. This is XML, XHTML, XSLT. I don't remember if there are any problems on the Impulse platform related to XML and XSLT. Anyway, that lab task is not required. But if you are interested, you can look at the problem examples over there. I may ask you several questions from this course at the final exam, but this is uncertain as we don't know how the final exam will take place. So I'll give you more details about the final exam and the XML course relation with the final exam later on, after we know when and how the final web programming exam will take place. Okay, so bye for now.